The second day of the International Phytate Summit saw new research into how essential minerals such as zinc, copper and calcium can interact with other feed ingredients and unlock greater efficiencies in animal nutrition. I've been speaking with some of the presenters and delegates to find out more.
We set a nice foundation yesterday of learning the basics, and now really getting into that area where we can apply some of the knowledge and transfer that into actually formulating diets and feeding pigs, in my case, is a good first step for today.
I really appreciate the discussion around the understanding of the underlying mechanism of mineral digestibility or availability.
I will talk about phytase a little bit, and I will make the point that phytase does increase calcium digestibility. I'll show you how we can formulate diets based on those digestibility values, and that allows us to study how calcium is absorbed through the cells or between the cells, and which transporters are used and which genes are expressed in that process.
The conference has underlined sort of the comparative nutrition. We've seen the differences between the pig and the chicken, whether it's in phytate availability or perhaps an inositol requirement.
So I do mechanistic modeling of phytate degradation, so it's really interesting for me, and in general it confirms the mechanism we have in the models.
What I will try to do is focus on the absorption in the small intestine mainly, as well as the transporters that are responsible.
So we are in our practical diets in a situation where trace minerals like zinc, manganese, and copper and iron are bound to phytate.
We have to do our research, but it has to be applied. It is important to share our experiences and our challenges.
So today I'm going to be talking about some work that we've done in the U.S. catfish industry on phytase superdosing. The one that really jumped out at us, so we saw almost 90% more iron in the livers of the phytase-treated fish.
Today's presentation is about woody breast, which is basically a muscle myopathy that is believed to be caused by local hypoxia in the tissue, which creates a state of oxidative stress. One of the theories that we had was that inositol, if we could break down phytate or IP6 to pure inositol, inositol is reported to have some antioxidant capacity. So that's where this whole concept of superdosing in phytase came about. I think it kind of caught everybody off guard. They're not sure what's causing it. So there's a host of universities around the world, and including in the US, that are specifically looking at what is causing woody breast and how can they help reduce the incidence of woody breast.